So I gather that this session, is more opportunity to ask questions of all of these speakers. Maybe I'll just start with the following brief thought, which is telescope time for speckle, at least from my perspective. I go through periods where, I wake up one day and I think, wow, this is great. We have these great opportunities. I'll have a run at WIN. Last summer we got to use Gemini. Everything's, it's just great. There are some, large telescope opportunities for us. And then other days I think, oh, it's all crashing down. Yeah, we're never going to get time again. And so oscillating between these two extremes is sort of, I think, what's basically going on. I gave my talk on the WIN telescope, but the reality is that, as some of you probably already know, that's at Kitt Peak. Kitt Peak has major problems right now, and it looks like the National Observatory facilities may close down there. Now, that's not the only thing going on at Kitt Peak. There are universities that have vested interest in some of those larger telescopes on that mountain, but it's a serious blow to the U.S. astronomy community, I think, and that's one of the things that puts me in that more pessimistic mode. So, nonetheless, I think in this environment, I'm sort of hoping to continue to observe on WIN and maybe get a little bit of time on Gemini North over the next couple of years, but I really don't know what's going to happen after that. And that's sort of an open question, I think, for all speckle observers right now. So I don't know, maybe I can pass the microphone to Bill, and he can give his comments as another person who's done this for quite a while.
Yes, for a long time. We had the same issues. When I first started at Georgia State in 1981, we had at least 2 runs a year at the Kitt Peak 4-meter, and then we started getting 2 runs a year as well at Tololo 4-meter. So we were getting wonderful quantities of data. We had the highest possible rating for proposals for observing there. Then the next time around, we were not given time at all. So the changing telescope allocation committees had different priorities. So double stars were not one of them. That's why we actually started observing at Mount Wilson, where we still had the grant money to rent the 100-inch to go observing there. So it's gotten much more difficult for double star observers to go on the big telescopes. We can occasionally do that from the USNO, but we have to have very specific, not open-ended projects. And you know that with double stars, much of it's open-ended. You need to observe things for years. So, but we have to have very kind of specific duplicity studies of this type of star, and one run will do it for us. You sort of have to throw in a few interesting objects as calibration systems, while you're there. But yeah, it's often quite tough for us to get observing time, even on what are now considered pretty moderate-sized telescopes.
I don't know. I think that sort of, to me, for the amateur astronomers in the room, is maybe a good thing, because you have a lot of opportunity to make an impact here, and if you can manage to, get your observing techniques down well enough and keep them calibrated well enough, then you may fill a void that could potentially exist in a couple of years when there isn't much 4-meter time and above for speckle. On the other hand, I guess one other comment is that when you talk about speckle, I think that people are realizing that you can do more things with it than binary stars now. That's why it's being used for Kepler follow-up and so on. But it's as Bill said, you really have to be imaginative about your proposals and have them focused. And long-term projects really are not seemingly the way to go. So maybe Ed, you have a comment from your perspective about the upkeep and maintenance of your observatory. And
my wife keeps me up, and so I think it's a wonderful opportunity for amateurs. I mean, if you can do pixel autocorrelation rather than true speckle and get within 1 arc second of a double star with an 8-inch telescope, the world is your oyster, huh? Especially if you happen to be someplace where the seeing is better than where I am. So I think there's a tremendous amount of opportunity for what is Brian called them unpaid research astronomers to really contribute and to get into systems that are not simply, and to get into studies that are not simply measuring things, but also looking a little bit at their astrophysics. And what I found in kind of going along that route with my good colleague Francisco Rica is that the math is not as intimidating for some sorts of projects as one might imagine. So I think the future's bright, at least for moderate-sized telescopes. And if it's pixel autocorrelation and not speckle, there's no reason you can't do it with even smaller telescopes. Maybe you can't get as close, but I suspect a 3-inch telescope would probably be pretty good for a lot of this stuff, as long as it's high quality.
I could add that there's been a lot of talk about educational opportunities, and one of the fabulous advantages of having the IFA here in Hawaii and having the Falks telescope available is to be able to get school kids together that have never had any experience on large telescopes and foster projects, and get by doing it with them, you get your project done. You can do a project with the kids, and the kids get a lot of great experience, and the facilities are available, not just here in Hawaii. Obviously, from what I've seen here at the conference, there's great facilities all over the country that are open to educational opportunities with middle school, high school, graduate, and college and postgraduate programs, and so I highly laud that aspect of the astronomy community and allowing kids to get involved, and that's one of the things that's helped me being an amateur and having not a lot of training or experience, and I've been able to help get the kids together and get used to some fabulous equipment and some great assistance by really great, knowledgeable astronomers. So we can appreciate that, and there's probably lots of ways to get involved in communities around the country that have programs that are open to that. I'm sure there are. It's just a question of beating the bushes, getting a hold of Russ and say, "Hey, Russ, I want to do a project."
I guess I could say that I think that it would be good for the professional astronomers, and we could maybe time for us to start using the amateur astronomers and guiding them with our projects. And I mean, that's been very successful in like the transiting planet community, and I think we could get a lot back and forth between the amateur community. I also want to say, I guess, that I was pretty intimidated by the math that goes into the speckle interferometry. I still am, but you can get around a lot of that. You don't have to do all the math yourself. A lot of people have done it for you, so you can get into it without being too intimidated.
Yeah, I think I've heard that before. But there's another half of that, which maybe Russ can talk about, and that is that, you know, when I got to know Russ, he was talking about how he was getting students interested in double star work. You know, I think part of the reason for that was because it's something tangible for students, and that side of it is actually something which really fits well. So can you, Russ, maybe talk about the pros and cons of speckle in terms of, on the one hand, it's double stars, so students can kind of get into that easily, but on the other hand, there's what do we have to do to get folks to get beyond this math hurdle, I guess? What are your thoughts on that?
Yeah, and you know, we're addressing it. We started addressing it this past fall, where we had a team that actually used the MCCD camera. They did Lucky, but they actually used the reduced program do it. And the difference between that and speckle is you click a different one on the on the reduced program. And I don't think that the students necessarily have to know the math behind the actual solutions that you come up with, but I want them to know the math in terms of what we're doing in calibration and the internal errors and external errors, and so that part of the math. And is Vera here? Oh, okay, very per head. At any rate, we've had a discussion and with Tom about if we only did speckle and we only did it at a large telescope and only a few students could go, maybe that wouldn't be much of an experience for the rest of the class. And so probably what we'll do is we'll mix in where some of the students can do the eyeball on the telescope with a simple eyepiece. I have a Liat filar micrometer that I've gotten that we're going to try, so that's kind of advanced eyeball. And then maybe we'll do some wider pairs, luck imaging. But my heart in terms of where we're going is I want to do some runs, kind of work through what it takes to get at least some of the students in a seminar, and maybe from students from more than one institution, to go to a somewhat larger telescope. It could be a half meter out in the Mojave Desert or the 2.1 meter at Kitt Peak, or maybe someday a couple students go down to, we got our eye on the 100-inch that Bill talked about. And so where students then are part of and maybe being advised, like folks like you would be advisors to the effort, but where they're doing, essentially cutting-edge science, maybe not the 4-meter telescopes, but maybe the half-meter to 2-meter, using speckle and using as many of the tricks as we can that doesn't involve where you have to have Linux and code and things that it's not explained, that hasn't been worked out. So anyway, I think it's going to be a fun area to explore, just to see in the double star area how far students can go.
Just a real simple one. Is Reduce Windows or is it Linux?
Yep, Windows.
Free. You email Florent Los and emails you back with the link.
Okay, I have a question. Comments. Basically, based on what I heard is, this is double star, is traditionally is very important and later become more and more challenging, as I heard, right? But on here, this is a very fundamental measurements. I see, Bill, you guys work, many years. Even tomorrow I show my talk, we benefit from you guys measure. We now can find pennies around some of these binaries. So this is indicated is very fundamental. But on here there is, the reasons why it get more challenging for big telescope, I think, is because bigger telescope have to do more other science, like extra pennies, some other things. So I'm just curious, because based on what BJ talk, it does remind me actually, people now can develop some kind of package. If that package, I'm just say, made available to the entire community, for example, and you can think about, the whole world. I know, even I went back to China visits, I see some of the high school, they have 1 meter telescope on the dome. So in other words, so this 1 meter telescope now is pretty much, in my opinion, is more like a educational and amateur kind of level kind of possibility. And now if, for example, let's say we make this called, now so-called citizen astronomy, right? As we know, even my student now joined Yale, and a former student joined Yale, they found a lot of, the Kepler, habitable planets with citizen astronomy, basically, right? So what I really mean is if we can, for example, say make it, if this is getting very serious, let's say we get the program available and very easily to use, and then that the college and high school or whoever doing use education, use whatever research, they can basically put into maybe one of the catalog somebody, a professional astronomer, put together, and with the program there, and they can grab some of the targets. I can use training students. They can take the volunteer data, but that data is, because they can do speckle, they can do lucky imaging, whatever the data they can feed back to the website, and that can over 10 years or 30 years, you can accumulate far more than you guys did, with maybe 100 nights, 1 telescope or something. So that I think the turn around, so you can get a very data rich kind of accumulations over times.
One of the problems with American education is that if you go ask a teacher to do that, they will say, where does it fit into our lesson plans and our standards? And if it does not fit into their standards, they won't do it. So you have to, there's more to it than simply telling schools they need to do these things. You have to fit what you want them to do into the standards that they have to teach to. If you do that, then I think it would be very successful.
Well, in many ways, it could be part of the physics experiment. About Kepler, Kepler physics, and those I don't know. Kepler physics is a high school according now, but that is at that kind of level. So you can imagine, students when they try to learn Kepler law, they can doing experiments with telescope. And in fact, when, for example, I went back even to China, some of the university, they have this 1 meter telescope at the building top. They have the education that I'm pretty sure that is some way those telescopes can use definitely do these kind of things.
Yeah, but you don't. But you don't understand the depths of how can I say it, of American schools of education and how they do things. You have to give them some goal. In other words, there has to be something. If you're going to do it in real school time, there's back in the back can illuminate on this. If you're going to do it in real school time, then you have to have some standard you have to teach to.
Real quick comment. I apologize. I had duties, so I missed part of the conversation. But what we've done, for Ed's point, education bureaucracies have nothing to do with education, and for largely.
I wasn't going to say that.
Well, I'm going to be a little. Well, I'm in education, so I'll say it, and you are too, and you know it. So the point is, what we've done, and JD could make better comments about this, but I've personally looked up the state DOE standards. You go through their list, and you go, it's XYZ 2.3, whatever. You do that, you give it to them, and they go, oh, wow, this is great. And if you do that for them, they're all on board, although they won't know how to do this stuff. But that's the only way. If you say it's great, we're learning Kepler's laws in physics, nobody cares. They're bureaucrats, right? So you just have to look. You have to look up these things and hand it to them or email it to them, and then it works.
Let me just add that I don't know whether Gian, whether you were kind of thinking about undergraduate or K through 12.
You can be high school, you can be middle school, you can be college, because they have a lot of this kind of telescope at those college level or maybe high school level. Those can be used as part of education training or something, and then you can get free data taking. And some of the targets probably take over again, but that's all you need, right? Because some of the binary is 30, 40 years. You need somebody just take data and add to it. That's all, right? Done.
Well, I don't think I can address the education system and all that, but as far as the other aspects, the software, things like that, it sounds like with Reduce and things. That stuff is available for any teacher who wants to use it. We are very happy at the Naval Observatory. We create observing lists and finding charts for anybody who wants them to whatever specific. They tell us what telescope they have, where they are, and we'll produce observing lists for them of objects tailored to their needs. So they can get lots of objects to observe that fits their telescope, whether it's a half meter or a 4 meter on top of their school, whatever. But so I think those aspects I think are pretty easily covered, and I think speckle systems and things like that are getting to the point where, well, good serious amateurs can do them, and I think school districts could do that sort of thing. So I think all of those are not major hurdles. I think it's more probably battling the education bureaucracy to get that sort of stuff in schools. And yeah, we welcome any data from amateurs as long as it's done thoroughly and reviewed properly, and hopefully published in a good spot like JDSO. We are always take it, and enjoy it. It's a fair fraction of the data that goes into WDS is from amateurs.
Some kind of textbook, some kind of education standard, and give the package to the bureau and convince them and be part of the education.
Well, easy and bureaucracy are not sort of two.
Okay, yeah, Bruce.
Yeah, this is American culture, not Chinese culture, so it's better to work from the bottom. My problem is with opacity and transparency. For me, the model that the Double Star community should be pursuing is Galaxy Zoo, where you just have a huge database and amateurs can kind of plug in and do research on their own, and discoveries can be made and classifications can be done and so far. The problem is with Double Stars that the complexity of both the methods of measurement necessary and the type of data that needs to be collected are like orders of magnitude higher. So it seems to me that what the Double Star community should be pursuing is some kind of a transparent networking community or culture where you have the facilities online to give people the software tools, train them to the software tools, validate their data through kind of a network collaboration of cross-validation and so forth. For me, just sitting and hearing all the talks today, I was impressed by how little I can take away. I don't really know what the cameras are that I should be using. I don't really know what the technical adjustments are to the equipment that I need to do before I can start observing. I don't know how to plug the data into the software. I don't know how many days or weeks I'm going to have to spend stacking and selecting and calibrating and adjusting and so forth. And that all of those are kind of opacity layers that need to be handled through some kind of a training program. If you had a training program, for instance, online, I think the sky would be the limit. You could get thousands of people contributing.
We'd be glad to do that. Let me tell you, to reduce 1,000 images to a corellogram and measure it takes a little bit under 90 seconds to 120 seconds. Maybe a little bit more than that. So, but I think the point is that maybe the problem is there's no one resource you can go to find those things out.
Yeah.
Perhaps that's what the problem is.
To the educational opportunity, it's also an upsell opportunity for you guys. I mean, once you have a sort of community of collaborators, then you can go to the educate. I think it's an upsell opportunity for the Double Star community. Once you have a sort of network of collaborators, then you can go to educational institutions and you can say, this is something that's ongoing, like 4-H projects, for example, and get educational credit for those things because they're already established and a lot of good work is being done with them.
Yeah, just to respond to that, just a minute, I don't want to take too much time. I've been involved in that kind of project before in a completely different field, and it's not anywhere near straightforward to be able to do that, especially if you're looking for funding from one of the government agencies. Yes, exactly. Because once you hand it over to the process people, as we call them, strange things happen to you, and you wonder if you even had the same project you began with. But I think Frank had a question up here. Or Russ.
The response is, I kind of envision this workshop and a number of workshops. I wanted to try to hold one a year that are kind of similar, where we get professional astronomers and amateurs and educators and students together. And so one of the goals of this series of workshops is going to be to essentially increase the cooperation between the professionals and the educators and amateurs and so forth, and particularly in some of these advanced techniques like lucky imaging and speckle interferometry. And so besides the workshops, and I think it was a good point, with what are the cameras and just how do you go about doing this? We're going to have, from each conference, we'll have a book that not only includes papers from the conference, but we'll ask other people where we know there's holes to fill. And in the past, we had this series of conferences of about 10 of them over 10 years on computerizing telescopes and observatories and doing automation. And the technology got transferred. And so I think we can do the same thing. I think the cameras are getting low enough cost now, and the software is advanced enough that we can now expand the number of people. So I think one of the questions that Gian kind of asked was, as we have an increasing number of 1-meter telescopes that are available, how scientifically useful if we expand our group of people doing this kind of speckle interferometry on 1-meter telescopes, can they make a real scientific contribution, maybe as the number of 4-meter observations drop off?
I think the one-word answer to that is yes, but from my point of view, and I'm going to defer to Bill after this, is just to say that calibration is a real issue, to calibrate well and to make sure that your measures are at a certain standard.
Yeah, calibration is always the key. But as far as 1-meter telescopes making useful contributions, well, we have a 26-inch. It's what we do most of our data with. So we like to think we make a useful contribution with it. So definitely 1-meter can do it too.
Okay, so the queue is Bobby, then Frank, then Phil, then Joe, and Gian. Okay?
All right, so a quick aside, as a high school student, I can shed some light on the high school research part of all this. You do bring up some good points that you have to get it through the bureaucracy if you want to be teaching this double-star research and getting students involved. However, there is a very easy workaround, and I do this at my high school. I'm part of a robotics team, and the robotics team, it's not part of the core standards, so it can't be taught as a class, but starting a club at a high school is incredibly easy. I could just sign a paper and I can start a double star club. So one way we could get more high school students or even middle school or elementary students involved is by starting clubs. But of course what this involves is having people like me to kind of spread the word to my peers that this is interesting, and there are incentives like coming to Maui. Stuff like this. So that is one way to get more students involved and possibly, get more for future research, because you get them young,
I want to respond to that, or?
Great thought.
Okay. I think it was Frank next.
I cashed in a lot of my Christmas gift cards to get D.H. Heinz's book on double stars, binary stars, and it's really old now. It's from the early 70s. It's pre-internet. I was wondering when we're going to get a 21st century 600-page resource that would bring a lot of this stuff together. I mean, it would be a big asset to people that are trying to study or get into the field, but there's really not. It's not really concentrated now. I was wondering if any of that is in the works from our leaders.
Well, there's Bob Argyle's book, which is pretty good, I think. And I don't know if you want to add.
That was what I was going to suggest. I'm afraid I do enough. I keep too busy already. I'm afraid my wife would kill me if I tried to write a book on this, and I don't feel qualified to do it anyway, actually. So there are much better folks for that than I am. Yeah, and Bob Argyle wrote a good book about it all. It's been revised. Is it? Okay, good. Good.
So now it's over to Phil, and on my way over there, I'm going to say that we're going to have a proceedings from this conference that will be really good.
I was responding to Bruce's point about how you get the various levels of information out to people at various levels. And I think that the AAVSO is an ideal model for this type of thing. AAVSO is dedicated to variable stars. So it wouldn't work for double stars because they have to restrict their range, their bandwidth, I think. But it's full of amateur professional collaborations. There are lots of articles at various levels about variable stars and how to observe variable stars. There's very advanced stuff going on under the auspices of the AVSO and very elementary stuff going on. And I would say that once people get together enough and talking about this enough, you could set up something along the line of the AAVSO. You'd have a really good organization. You'd be able to get a lot of people involved, and you would be able to circumvent the school system entirely. Okay. Absolutely. And we do online courses. AVSO now has a program of doing online courses, of which I've taken a couple, have been excellent. They range for mentors in the community. They range for speakers at astronomical societies. All kinds of things. If you can imagine it, AVSO is probably already doing it in the double star field.
Maybe Kent has a comment or two along these lines too about, in terms of publication and.
Well, I mean, one thing that has occurred, a bit of a historical thing, is when I first started the JDSO, I didn't imagine it the way it has become. I imagined it to be a little bit more of a general interest thing where we'd have some measurement papers, but then we'd also have people who wrote papers about how to do some double star things. And instead it's become something more of a, like a regular scientific journal, where I had envisioned it to be a little bit of both, maybe a sky and telescope for double stars, along with these more technical papers. And if somebody wants to write some papers about how to do this and that, I'd be welcome to publish them.
Yeah, in fact, I was going to suggest maybe invite people like Florent Loss to write articles along those lines, and people have used specific instruments and done really well with them. Write more articles about how to do it. I think that'd be very useful. Get a series of them together as maybe a special issue.
That's a good point.
Kent, before you leave the microphone, is your university willing to host a website?
I don't know. I'll have to find out.
Okay.
Because
if it is, I'll volunteer to help set up a website that would act as a nexus for this. But I think it would be appropriate if we did that it be hosted by your university, since that's where JDSO is. And if we get that kind of website thing going in synergy with the JDSO, that will then be a possible magnet if anyone actually wants to form an official organization.
All right. We'll talk about that some more.
Next in the queue is Joe.
First, Bobby, how did you know that I came here because did astronomy to get here? Your motivation for motivating other people. Anyway, no, I'm just kidding. Okay, so Ed started to touch on this, and so I'm involved with a number of groups that are interested in things like interstellar travel and crazy things like that. And one of the things we've been discussing is doing some sort of wiki, and Ed almost touched on this, and I keep hearing, I've had a lot of questions about what camera, how do I get light in through a fiber into my spectrometer, where do I get this algorithm? I keep hearing, well, this will get published, there will be proceedings. I'm not volunteering for this, but I wonder if one of you have a student that maybe would want to set up some sort of wiki. And then people could just, when they have time, we log in, and there are a bunch of us people in the astronomy community who could do this. It would be something that was self-maintaining and growing if somebody would just, that'd be a very effective modern way of transferring some of this information. Somebody goes, oh, I've got a new camera, I'll write a paragraph on it. Does anybody have a student that's computer savvy that could do that? That might be a very effective way to do some information transfer.
I think that my motivation. I think you're absolutely right. You could set one up if Kent was willing to. If Kent's servers were willing to host it, I think the wiki format would be actually more useful than what tends to be static web pages which never change from day to day. And a lot of that stuff could appear that that might have gone into the JDSO, but since you have an outlet on the web, could go on the web, especially stuff that's repeated information like how to use reduce.
We have two people joining the panel here. So you're up there, like, you're on the panel. Are you sure? Okay.
Something like that. They're not that hard to set up.
The double wiki.
There you go.
Wiki.
But it's a modern, effective way to do this, and it's not very difficult, I understand, and I'm not volunteering, but I know several of you have very sharp students that can do things like this. Just an idea. You have to do that on any website.
Okay.
Self-moderating. Yeah, you can be self-moderating. Well, let's not shoot it down yet. Just find a student who would do it. I mean, the point is, it's very. Who in here has not usefully used Wikipedia? Okay, that's my point, right? Things like this are great modern tools if you're really trying to share. And somebody comes up to me and says, "What camera?" I'll just go, "Oh, check this wiki," and it's self-maintaining sort of because there's such an enthusiastic community. So just an idea.
It looks like we generate a lot of interesting discussion. But I do want to say that you guys have to keep in mind, we talk about, the one side, the other side, there's many sides actually, from the amateur to education to, professional. They have different kind of feeling. So my sense is we have to look at the evolution of the technology. I remember 20 years ago when I was an undergrad student, I heard somebody give talk on speckled interferometry. I was kind of scary. I said, wow, this is fantastic technology. But when I came to the United States, become a grad student, I realized this become like dinosaur kind of technology in some ways. But now, of course, thanks to you guys doing this, now I realize this technology now is becoming rejuvenated again, in many ways, because I think maybe because of the detector, and also like imaging now is getting there, because I think there's not to do with mathematics, not a tool. So therefore, I think Bruce got good points. It's the way I think that why amateur is the scale of these kind of things. Another way to do is the lack of background education, the kind of basic things. And you got a very good point. I think it's in a way, if there's a community, for example, organize this, and to have this, first of all, have this kind of, introduction, basically, introduction to use speckle, introduction to use the lucky imaging or something, and that is the basic part of that. And the second part, also give the recommended price or something. I'm very practical because it's some way if you think about high school or college, if you talk about $1 million, forget about that. If you talk about magazines, in $10,000, they might be happen. So therefore, this is all a variety of things we can target the different kind of level. I know you guys talk about calibration could be issues. I agree on that. But on the other hand, there's always different level. For example, people can take data, they can leave data, and with the standard calibration, and then the professional people can grab data, they can make improvements. For example, there's a many variety of way, but set some standard. For example, the data becomes shared among the international community, and then with some professional way to process it. This will be enormously enhanced this field. That's my number one comments here is, so it's really need people put energy there, like what Russ tried to put, education and college student and also the professional people like us and amateur as well. So this is certainly the first time I see this meeting with mix this together. I now starting to enjoy this. It's really important to bring different perspective, and this can be done. I think it really can be done. And the wiki is one way to go, but but certainly I think it's the way definitely move forward. But I also want to point out the other issues you guys probably want to consider. And first of all, technology now is suddenly advanced, but on the other hand, scientifically
And the double star, to me, initially, when Russ invited me to come over here, I was reluctant in some ways. And but after learn, I really feel this is certainly have a lot of cutting edge there as well. But on the other hand, there's a lot of exciting things going on with stars, like exoplanets, like transits, at double radial velocity. These things all can be linked to double stars. So therefore, when we talk about double stars, we don't have to be just talk about double star itself. We can talk about what's happening with stars. So link all these together, outreach to the exoplanet fields, maybe some other fields. That will be enormous inject energy to make this field very, very exciting. In a way, eventually, not only make this, with the open, or all kind of things can be eventually make internal-wise, to inject to this energy that, increase the education, outreach, and the scientific productivity. Eventually, we can have, not only 100,000 double stars, but maybe billion stars, measured over 10 years or 20 years. These kind of things.
I think I just want to agree wholeheartedly that the exoplanet area, the interface between binaries and exoplanets is becoming pretty hot right now, and so I think that this is a way that the double star community can make a difference again. Like many things, it goes through periods of it waxes and wanes a little bit, but I think that this is the next big opportunity, and that's one thing that makes me more optimistic about the future. Another comment is that I think BJ, you did some of this as an undergrad, and then now you're kind of into the exoplanet track, right? So maybe you can speak about this just a little bit.
Yeah, maybe. I guess I could see how double stars can be very important to exoplanets. I mean, especially exoplanet formation. I think we need to understand, binary fractions of exoplanet host stars, and I think that would be really useful. I think that would be a way to kind of make the double star field a little sexier. Yeah, it's a good idea.
What is that fraction right now believed to be? I've only heard of one.
No, I think that there's many.
Yeah, I've only heard of one.
Yeah, I don't think it's completely clear what the fraction is, but there's many systems that are in double star systems. Yeah. Not necessarily circumbinary. There's a difference. One star is orbiting, or the planet is orbiting one star, and then there's a widely separated binary. That happens in a lot of cases.
I will talk about it briefly tomorrow, with some kind of planet discovery in the binary as well. So this is kind of now uncertain at this moment because people are afraid of binaries. And but the general sense now, is if closed binary like 10 AU or 20 AU, the percentage seems to be low, and lower than the regular single stars. But it's not that low to the point that you couldn't find planets. And in fact, tomorrow I'll show one of the major discovery from our group is unbelievable massive giant planets in the brown dwarf, a very compact binary system. So it's not a second binary, but instead it's just around one of the primary. So this kind of thing is a kind of untested territory. I think that can link very well to the double stars in a way, like BJ said. In many ways, double star, in my opinion, is more like an excellent laboratory, because you got another guys perturbate the system, and then once you have the discoveries, that can tell you how much that play role, and compared with single stars, because you got this control sample. Right, so this is really good for planet formation. People haven't fully appreciate that yet.
Yeah, actually, my history was I went from exoplanet stuff to speckle to follow up exoplanets, exoplanet discoveries, and it was just kind of another tool I could use for exoplanets. I was doing exoplanets the whole time.
At the risk of changing the subject a bit, I was really impressed with Dr. Malkov's talk about the distinction between dynamic mass estimates versus photometric mass estimates. And I run with a gang of photometrists. Could the panel, Ed has shown that
we can clearly get to the 1 or 2 arc-second separation, maybe a little below that. I'd appreciate any thoughts that you all may have on additional opportunities for amateur projects beyond separation and position angle measurements that would be useful to astrophysics, to you all, to the world.
As an amateur, I mean, I can respond the following way. People like Francisco Rico have been doing this for a while. I mean, he has a lot of mathematical skill. He reads the literature. He's not a professional astronomer, but I think, I don't know what other people who know him think, but I think he's a pretty cool guy. I mean, he's the amateur that I look to as the amateur astrophysicist I can trust. He and I are now working on a project in which you do these things to find out if these well, these are Struve pairs that have common proper motions. They have the same distances. Okay, they're main sequence stars, so you can figure out the masses doing exactly what the astrophysicists tell we should do. And so with that and the radial velocities, you can actually see if there's some possibility that they're gravitationally bound as compared to, say, just being common proper motion pairs, common origin pairs. And that's something that I'm now working through, and it turns out that's simple enough. That's simple enough astrophysics that a retread biologist like me can kind of understand. So that's the sort of thing, if you want to go further, it seems to me that amateurs could do. But these papers need to be taken seriously enough to be reviewed critically by real astrophysicists to see if we're just not spitting in the wind, if you wish, because a lot of us don't know enough. We don't have enough deep knowledge of astrophysics. We're kind of like, you tell me to do this and I go do it, and I think I kind of understand it and the numbers make sense, but then someone who's really an expert will say, oh, that's a bunch of hogwash. You shouldn't be doing this because you have not met this assumption, you have not met that assumption. So if we're going to go do those sorts of things, it's going to be kind of like, you've got this new, pretentious new graduate student who wants to write something. Oh my God, I'm going to have to read his paper, and that's going to be how the professional community is going to have to respond to that sort of thing. And I don't blame them if they just say we don't have time to do it, because I'm a professional research scientist too, and in a completely different field, and I understand that professional research scientists don't always have the time to look over and critically review what some amateur has done.
Okay, well, so one obvious difference between the professionals and the amateurs is the spatial sampling in terms of what you would consider a Nyquist sampling over the surface of the Earth, right? And so I forget who it was yesterday. Somebody said something about occultations. And for people who are interested in timing transient events and stuff, just the spatial distribution, things where you have to have bunch of people to get different spatial distributions for precise timings. I think there are a number of things like that. That's certainly a place where there's value simply because of the spatial distribution.
Ask a question real quick. Okay, I'll let you go first.
I wondered if one or more of you could comment on some of the calibration. So I'm kind of interested in, could amateurs use slit mass? What kind of calibration procedures, as we move forward and more people did speckle interferometry, say on 1 meter telescopes, how could we meet this concern that the calibration was done well and properly, so the results would really be meaningful?
Why don't we, I don't know, maybe start with Bill and go down this way then.
Yeah, that's where we need a wiki. I don't know how to do this.
Offhand, I would think that with 1 meter telescope, you could do a similar thing that was done, as I showed with the 2.5 meter. I wouldn't think it would be that difficult to, if you can get access to the front end of your telescope and you have a good firm way to put a slit mask in. I mean, something as simple as the one that was developed for Mount Wilson. and it's compact.
That's from your professional point of view. But for people, amateurs,
Oh, there are lots of amateurs.
There's no such thing as a 1 meter telescope. There's 0.2.
No,
that is you talk about individual, but I'm talking about people like high school, college. Those they really have the 1 meter telescope.
Find one in Kansas.
I don't know if you have, but I'm surprised when I visit China. I see a lot of high school they have this 1 meter just for decoration. I just say, wow, this is crazy, telescope.
I'd have to look that up, but we get well, 2/10, I guess, of a degree. In theta, we get the 0.5% accuracy in the scale. Oh, how the tolerances? Oh, that's been quite a while since we did that. I don't know the numbers offhand.
Just to follow up on what Russ was saying about calibration, 3 ideas that maybe you guys can review. One is to recommend standard equipment, standard video camera, whatever, standard mask design you can put on the web, people can copy it. Second thing is that I think with Phil's experience with the AAVSO, they validate people by having them measure a known entity. So you could have known primary stars or test primary stars, or even a star with a field star that's not going to be in any catalog, so they can't book the answer, and have them measure that and see how close they come, and don't let them submit any measurements until they reach some criterion. The third thing is, it's kind of puzzling to me as a statistician, but it seems to me that when you guys run OLS, you run 19th century OLS, where all the measurements have equal weights. And in my training, you can put in Bayesian kinds of stuff where, a good judge gets more weight than a bad judge. So, and that kind of thing could be applied to observers as they train up, where you sort of increase their weights as they go along.
Oh, when I developed the orbit catalog, I determined weights of all observers. I think I used 1,000 orbits and about 100,000 observations, and did all sorts of comparisons between the two, scaling by size of the apertures and the separations of the pairs they were looking at, and many other factors. So yeah, we do quite elaborate weighting for doing good orbit. Yeah, right. We can easily see the really good observers from the really bad observers. I mean, they usually stand out pretty well.
Can I make a comment on the same topic, and that is that I think it might be useful if in Reduce we could build in a routine, or have the author build in a routine for a standard calibration that was based on a mask.
Well, I mean, Reduce just measures things. So you have to give it something.
Yeah.
Yeah, right.
Well, but I mean, it measures, your double star observations. That's a little bit different from the pattern you're going to get from the slit mask.
Oh, yeah, right.
And so we just need something in there that could be used by the amateur community that would automatically reduce the slit mask observations in the same way.
Yeah, so long as you're using an SCT that has a lock mirror and only a Crayford focuser, so that your focal length doesn't change as you try to focus, or you lock it down. I mean, there's all sorts of problems that professionals don't face with amateurs. So guy's got his C11 and he focuses with this little thing, and every time he focuses, he's changing the focal length. Every time he changes the focal length, he's changing the plate scale, and he has to quit that and lock down the mirror and hope it doesn't change. And then what's the slit going to do for that focal length for that guy compared to another focal length? If there's an algorithm then I think it'd be wonderful to have something like that. And I'll bet you Florent could probably do something about it.
I don't think it would be that hard.
So on Russ's point, I'll just share a little trick I did 20 years ago, and I didn't measure the full bidirectional reflectance distribution function, but I used to do roll-offs with a good Lambertian plaque, and just for fun once, I did it with a piece of drywall. and it actually was, I got almost exactly the same roll-off curve. So if you guys are trying to do flat fielding and stuff with a small telescope, since you asked about calibration and something that's widely available, you can go get the drywall actually works very well.
Yeah, that's kind of what I was going to ask. Is there something that you can buy that will give you interference patterns of some sort? I mean, is there like Hartman mask, something that might help you with collimation or something that is off the shelf that people could buy that you could also use for this? That you could use for calibration. Is there something, some tool that that may be applicable to helping with collimation or some other aspect of your telescope setup that that also could be used for this?
I don't understand why you need such a slit mask for calibration of the measurements for emitters. Yeah. For example, on the sky we have plenty of objects which are very good calibrators. Take for example the Orion trapezium. Yeah, the positions, angles, distances are known with a fantastic accuracy today. So you always can have it. It's about 25 arc seconds between the components of this order, 20, 25 arc second. And you can make any calibration, scale and orientation. So why do you need this slit? The slit is also doesn't give you too much because you always put it in an orientation of this mask, etc. So it gives you also the fringes you get, or if you have a double slit or you have this long slit, so this also not precise enough. You have to measure with high precision the centers of these ports in the focal plane. So it always gives you some error. But on the sky you have plenty of objects like which are very good calibrators.
Right. And the Argyle book has a list of calibration stars that are all throughout the sky, throughout the year, and they're steady, even pairs.
But you want to make sure, but you want to make sure that you have them for that night, not last year or the last year the Argyle book was published. So that's why the rectilinear catalog is so valuable, at least to me, because you get it for that night.
So I think we're coming down at the end of this session. So I just had one last quick question, then we might run it down the line, and then we'll move on to the next thing. So I was wondering how many in the sixth orbit catalog orbits are, that's probably for Bill, are at the level 1 or level 2 grade. And if it's not very many, that's a really, really important thing to know these masses and stuff for a lot of different reasons. And is there any alternative or anyway?
Of the systems in the sixth orbit catalog, they're about 1,800 systems. It's perhaps 100 or so, just top of my head, that are of grade 1. Some of those are going to be extremely close interferometric pairs, done with long baseline and things like that, so it wouldn't be really applicable. Some of them for calibration turned out to be the class 5 orbits just because they're extremely wide, moving extremely slowly, so even if the orbit is garbage, it still predicts the motion very well for the next century or two, so it's about all we need. So a lot of good systems for calibration and such in the orbit catalog as well. But the rectilinear is probably the simplest to use just because it's nice straight line motion, very easy to calculate. There are also formal errors there in the catalog, so you can tell which ones are good.
Yeah, and I have a spreadsheet that does it for the night that you want. If you want it, I'll send it.
Are there any other questions? If not, then why don't we conclude this dialogue, and I guess many of you will go observing tonight, so that's exciting.